this note, I will hand you to Instructor Isaac. Thank you very much, Instructor Isaac, for being here tonight, despite your busy schedule. I hand the class over to you.
Hello, my name is Isaac. I'm currently for 300 university. So IT with ASAT. I take in the cybersecurity course. Currently, we were got one, got 2024. So we've completed cyber ops just last month. So we have to give back to the academy what they have done for us. Have me here on board. So just stay calm and let's see what the Lord. Hello, am I audible?
Yes, we can hear you. Of course, it was breaking for some, at some points, but it's better now.
Okay. Okay, so let's share a word of prayer before we start. Oh, gracious, everlasting Father, we are grateful unto you this evening for bringing us together to continue with this journey in cyber threat management. Father, as we are gathered as one family to study, Father, we pray for your spirit of fortitude, spirit of knowledge, wisdom, and understanding. For there is a spirit in a man, and the breath of the Almighty gives us understanding. Father, breathe your spirit upon us this evening, that everything that we will learn, will be able to make use of it. Father, do this and many others, so that we return all the glory and honor unto your holy name. Thank you, Father, for an answered prayer. In Jesus' name we pray with thanksgiving. Amen. Okay, so let's quickly delve in. All right, so we are on model 2, and the model is network security testing. Let's look at our objectives for tonight. So in this model, we are going to use tools for network security testing, where we'll be looking at security assessment. We use commands to gather network information and diagnose connectivity issues. We also look at network security testing techniques. We describe the various techniques security testing. Network security testing tools. So we also look at a brief overview of some of the tools that are used in network security testing, and we also describe penetration testing. So without much ado, let's start with security assessment. When you talk of security assessment, you are trying to evaluate the security posture of the devices that are in the organization. All right. So one way to evaluate the security posture of an organization, use a vulnerability scanner. So the vulnerability scanner assesses computer systems, networks, or applications for weaknesses. So you are scanning the various assets of the business in order to determine vulnerability. Okay, I'll work on that. What might be the problem? Please, is it audible now? give me a reaction for me to continue.
Yes, you are good.
All right. So I was explaining vulnerability scanner that this a kind of is a technique you use to access the various computers or the assets in the organization in order to figure out the weaknesses or the flaws that are in the security devices. You know, all the devices, before they will be able to function well, it is softwares that are built on them. Some of them, we call them firmware. So if there are vulnerabilities in the firmware, attackers can actually compromise the device. So it is very useful to have a vulnerability scanner to evaluate these computers uh, and these security devices in order to find out the weaknesses before the attackers do. So vulnerability scanners can help to automate security auditing by scanning the network for security risks and producing a prioritized list to address vulnerabilities. A vulnerability scanner looks for the following types of vulnerabilities. So these are some of the various types of vulnerabilities that a vulnerability is likely to look out for. That's one. It will check for default passwords or common passwords. In the sense that some of us, we still use the password QWERTY, that's QWERTY, or 1234. These common passwords, they are very weak to crack. So vulnerability scanners will detect it that there is a user in the system that is using this weak password. So you have to follow the password policies in order to create new passwords on your devices, secure ones for that matter. Sometimes you can use a combination of symbols, numbers, lowercase and uppercase characters. And it must be more than 8. Minimum is 8 and maximum can be up to 15. And also missing patches. Whenever the operating system or applications are outdated and the organization fails to update them on time, when you run a vulnerability scan on the system, you'll be able to determine the passages that are missing. Also, vulnerability scanners will reveal information about the ports that are open and the services that they are running. To proceed, misconfigurations in operating systems and software are also vulnerabilities that a vulnerability scanner can figure out. Active IP addresses, including any unexpected devices connected. So whenever you scan the system for vulnerabilities, you also find out the hosts, that's their IP addresses that are on the system, that some of them are not expected to be devices that must be connected to the system. Let's proceed. So vulnerability scanning is key to identifying vulnerabilities, misconfigurations, and a lack of security controls for organizations with networks that include segments, routers, firewalls, servers, and other devices. So in short, these network devices, most of them have flaws. So when you perform vulnerability scanning, you will be able to determine these weaknesses or the vulnerabilities. Vulnerability is just a weakness in a system that can be exploited. So some of the commonly used vulnerability scanners in the market are Nexus, Retina, Core Impact, and GFI LandGuard. You also have the OpenVAS, which is, I think is now known as the GVM. Sometimes Nmap 2 can perform vulnerability scanning. We'll look at Nmap in our subsequent slides. So these are some of the functions of the vulnerability scanners. They perform auditing. So when you detect the vulnerabilities in the system. So let's say, for instance, default passwords. So if you still have default passwords in your system, it means you are not complying with the password policies that are laid down. Supplying patches and updates. So like a vulnerability scanner will detect missing patches. So out of that missing patches, it will help you to also know that what you are not complying to the rules and regulations or the standards that are there, in the sense that when there is a patch available, you have to apply that patch so that the attackers will not exploit the vulnerabilities in the system. So when you use the vulnerability scanner to identify the patches, the vulnerabilities, then you supply the patches and update them as well. And the misconfigurations. So human beings are full of making errors. So anytime, any day, you can make errors when configuring firewall devices, when configuring access control rules on routers. So it is very important to use vulnerability scanners to detect these misconfigurations that may arise in the security devices, so that you can go a step further by rectifying them before the bad guys find out these loopholes. Also, it aids in supporting mobile and wireless devices, tracking malware, identifying sensitive data as well. Right, let's proceed. We have some of the types of vulnerability, type of scans that we do. We have the network scanners. These are scanners that we use to probe the host or the devices that are connected to the network for open ports. We enumerate information about users and groups and look for known vulnerabilities on the network. So that's typically what a network scanner does, like Nmap. It will scan the system for open ports and services, and it will determine whether the services are outdated or they are up to date. So once you determine the kind of services that are running on the system, you can update the services. Or if the bad guys do, they will research about this the service, whether it is outdated or not. And if it is outdated, then they will look for the vulnerability and the exploit that is available for that vulnerability. Then they will use it to compromise your system. Sometimes if there is no exploit for it, they can weapon, like we call that process weaponization. They can build their own tool to compromise the system. All right. We also have the application scanners. They access application source codes to test an application from the inside. So with this, you are testing the application by using its source code. So if there is any vulnerability in the application source code, like some comments reveal too much information. So in the source code of your application, you must avoid making comments that will reveal information about the organization to the attackers. And also we have the web application scanners. This way we identify vulnerabilities in web applications. So these are scanners that use to what? Identify vulnerabilities in web application. Sure, let's proceed. Also have the intrusive scans. This is where you try to exploit vulnerabilities and you may even crash the target. So the scans that are intrusive, they go a step further by exploiting the vulnerabilities, and they have that agenda of crashing the target system. Whilst non-intrusive scan will not try to cause any harm to the target. That one, they will just try to find information about the target. In a credential scan, usernames and passwords provide authorized access to a system, allowing the scanner to harvest more information. So In a credential scan, you are using the usernames and passwords to gain access to the system in order to gather more information out of the system. Non-credential scans, they are non-invasive because you don't gain administrative access to the system. So it will not reveal much information to you. However, all types of scanners can mistakenly identify a vulnerability where none exist. So sometimes a vulnerability scanner, because it is an automated tool, it can identify vulnerabilities that does not actually exist. This, we call it false positive. Like it means the alert has been generated, but there is no intrusion happening, or there is no weakness in the system. And also sometimes there might be a vulnerability in the system, but the scanner will not detect the vulnerability. This is the one we call false negative. Credential scans return fewer false positives and fewer false negatives. Because you've gotten access to the system by logging in, you are likely to get accurate information rather than the system giving you information that is a false positive or false negative. Right. Let's proceed. We have some of the tools that are used in the command line interface. We have the IP config, which is used to display the TCP IP settings or configurations. The informations include the IP address, the subnet mask, default gateway, DNS, and MAC information. That's the information. These are the various kind of information that the IP config will give. And the IP config, we use it on Windows system. But for if config is used on Mac or Linux equivalent, like we use it on Mac system or Linux system. We have the ping command. That's what we use to test connectivity between two or more hosts by sending an ICMP echo request to the machine we want to test connectivity to. Let's say, assuming we want to set something on Google. Before we will be able to access Google, we have to determine first, are we accessible to Google? So we have to make a ping scan. So the query will be like this: ping www.google.com. If we've gotten a reply, then that means there's a connectivity. So we can go ahead and communicate with the Google server that is available to us. So it's all about testing connectivity between the two systems that are involved, whether there is a network connection between them in order to share some form of information. They also have the app, that's address resolution protocol. This one, it provides a table that maps MAC addresses to its associated IP addresses. So anytime you want to transfer files on a LAN network, you need the IP, you need the MAC address, because the source host that wants to transfer the file is having the IP address of the device that it wanted to send the packet to, but it doesn't know the MAC address. So you have to make an app request, that's a broadcast message, asking who has this IP address. So inform me. So then that device will inform the one who has it with a unicast reply message. So the request is a broadcast to every device, but the device that match, like the device's MAC address that matches that IP address will reply, is the only device that will reply to that request. Yeah. I also have the triset or the trace route on a Linux system. We call it trace route. This one, it traces the route of a packet to the destination, like the different hops that a packet takes. Like when a packet travels or when I'm, for instance, when I'm sending something to any of you there, like the packet must travel through routers on the way, and we call the routers hops. So this trace set command, it will track the various routers or hops that the packet has gone through before it has finally landed at the destination device. So as of now, if I run trace route on the packet I am sending to you now, like I mean my voice packet, so you see it will pass through routers before it will get to your end. That's it. And you also have the NS lookup. This one is used to query the DNS server so that we can resolve domain name to IP addresses. So you use it to determine whether the DNS server is working on your system, so that whenever you type www.google.com into your web browser, can you access that particular website? If you don't have DNS working properly on your system, then you cannot access a domain name through the browser. So one way to troubleshoot a, a situation where your DNS server is not working is to use the NS lookup command. Let's proceed. We also have the net start. This command displays connectivity, the ports that are open on the system. So the various connections that are created on the system, the services that are established, the ports that are listening on the system. Ports are just reserved resources that allows applications to interact with it. So that's what a port simply means. So when they say different ports are open, you can actually use the net start command, or you can also use nmap to determine the different ports that are open. Each of these tools have its power. So with the net start, when you use it, you will be able to find out the processes that are running on that particular port as well. And we also have the net BIOS statistics, that's the net stat, like the NBT stat. So this one, it helps to troubleshoot net BIOS name resolution problems in a Windows system. So it's likely almost the same as the NS lookup command for DNS server. So this is for Windows system. And the nmap is used for net security auditing. We also call it the network mapper. It would locate all the network hosts, determine the operating system, and identify the services that are running. It will also identify the open ports. We have the netcat command. This one, we use it to obtain information about TCP and UDP network connections. And it is also used for port scanning, monitoring, banner grabbing. So when you talk of banner grabbing, that's where you gather information about the various services that are running on a particular port or protocol. So let's say HTTP port 80. When you want to grab the banner that is the Apache server that is running on the system, or the server that is running on the system, like what are the details. So when you capture the information, you'll be able to see the version, the client window, and some other useful information about the server and other services. We also have the hping command. So it's actually a utility as well. The hping assembles and analyzes packets and is useful for port scanning, path discovery, OS fingerprinting, and firewall testing. So with this, it's also used for packet fragmentation. You can use it to perform a stealth scan as well. So it's some way similar to nmap. It's used for packet crafting as well. All right, let's proceed. We have the security automation tools. So with the previous commands that we've looked at, we have the security information and the event management and the security orchestration, automation, and response, or the SOA. These tools are used in the security operation center to enhance security monitoring. So the SIEM, or the security information and event management, is a combination of two services that are joined together. There is one that is security information management and also security event management. So they have merged the two together. And these two systems, they are used to collect logs, aggregate the logs from different sources, like the security devices, as in from routers, from switches, from firewalls, server, NTP servers, and other applications. So the SIEM tool provides real-time monitoring and reporting to the system analyst. So logs can be generated many events in a day. Like log can generate many events in a day. So SIEM systems help to reduce event volume by combining similar events to reduce the event data load. So it's the SIEM tools, they have a feature called normalization, retention, data archiving. So all these features will help you to reduce the amount of data that you have to be viewing daily. It will aggregate the data. So the SIEM tool can also help you to identify deviations from the normal baseline and then take the appropriate actions. You see, when you set up a network, you capture a baseline of the network. So by so doing, when there are some anomaly or deviations in the normal operations of the network, you will be able to detect them. Let's proceed. So the goals of the SIEM is to identify the internal and external threats. Like the threats are any potential damage to the system. So to identify the damages that are within the organization or the ones that are coming out from outside the organization. You also monitor activity and resource usage. You conduct compliance reporting for audits. You support incident response as well. All right, I think I've spoken much on this theme. Let's proceed to the SOA. We also have it, I think, in the fourth subtopic, so don't worry about it. We have the security orchestration automation response. It is similar to the SIEM in the sense that it also allows organizations to collect data about security threats from various sources. But this one, it will respond to low-level events without human intervention. So some of the events that might occur, it doesn't necessarily require a cybersecurity analyst to review it all the time. It can sometimes respond to threat management and vulnerability management like this here. It also performs security incident response to automate the task of the SIEM tools. Also, it automates security operations. So it is likely that, or it's always advisable to integrate the SOA and the SIEM solutions to enhance the security monitoring of the organization systems. So we have a packet tracer activity where we use the diagnostic commands. So first I thought of it, we should first finish, but let's quickly look at the packet tracer. I've opened the file down, so let me finish it and close it so that it will not give us any challenge. So before we proceed with the presentation, we'll take some, I think 15 minutes or getting to 30 minutes view of the various activities here. So in this packet tracer activity, we are going to gather end user device settings. We also gather information about network devices, then we diagnose connectivity issues. So let's look at our objective. In this packet tracer activity, you will use various commands to gather device information and troubleshoot device configuration and connectivity issues. Device information includes IP address, default gateway, and DNS server settings. These settings are critical to enable a device to communicate on networks and connect to the internet. Let's look at the instruction. So step one is part one, we have to gather end user device settings. So step one is to document the IP address settings for the HQ laptop one. So we have the wiring closet here. We also have the PC one. So the PC one is here. When you hover over it, the name will show. So this is it, PC one. We also have the PC2 here as well. I think this PC3 is here. This PC3, this PC4. The HQ laptop one. So our various devices are. We also have a printer. So I think the printer is here. Yes, we have F printer PT. So this is it here. So we are going to access these various devices quickly in order to follow the prompts. So you have to click on this. Okay, so we are going to access this very first device, the HQ laptop one. So open it, go to the desktop tab, then open the command prompt. Then we'll type the ipconfig command. Ipconfig. So it will display IP settings or configuration information such as the IP address, the default gateway, and the like. So let's hit enter and see the information. So you see, these are the various informations that are available. Let me see whether I can adjust this. It's not increasing. So take a critical look at it. We can see the IP versus 6 address is not available. You can see the IP address here. You can also see the subnet max here, the default gateway. And when you do ipconfig /all, you will see detailed information about the various interfaces and the rest of the information that are available. Yes, so this is it. You can see here, you also view an information about the DHCP server that is on the system. So you can just copy the IP address and document them in your Word document in order to submit your lab. So this is it. Let's move on to the next step. All right. Let's close PC1. Okay. So we are off the command prompt. Now, see that we should enter ipconfig command. So they are asking us which IP address is displayed for the wireless interface. Let me see. So this is the IP address here. That's 192.168.50.4. That is the IPv4 address that was displayed. Let's proceed. And the other question is, if the IPv4 address is in the 169.254.0.0/16 range, what method is being used to assign IPv4 addresses? So if it is in this range, So it means the method that is being used is, I think we call something a PIPA. That's research on it is ARPIP. You see, whenever you do not get IP address on the network, it will automatically assign the IP address to the system. So we call it a PIPA. I think APIPA, a PIPA, is auto configuration internet protocol addressing. Yeah, one of these, I guess that's it. So you can make some research on it. My book is not by my side to verify, but make some research on it. But whenever you see any, or you can research on this 169.254. Yeah, that's it. Link local address or the APIPA, right? So you can research on that as well. And the next question is, what method is being used to assign IPv4 addresses? So if the IP address were to be this, then we will say it is what do we call it in Pope? The APIPA or the link local. But realize the case, it was 192.168, which is this. So the method that have been used is, I think, DHCP. Let's see more detailed information here. Let's see whether DHCP has been enabled or not. So okay, there's a DHCP server. So it was a DHCP server that was used to assign the IP address. So meaning in this context, the IP address has been assigned dynamically. Okay. Why is the laptop assigned an IP address in the 169.254 range? So if it were to be on this, they are asking why. Because if it is not able to obtain IP address dynamically, or you didn't set it manually, then by default, the link local IP address will be assigned to it. Okay. So if the IP address is in the 169.254.0.0/16, you have to wait a few seconds, then you repeat the if config IP config command again. But for that matter, we have completed all those ones already. So these questions are left to you to answer. I think we have entered the IP config command as well. /all, the one that involved the /all. Where is it here? I mean, yeah, this step D, we have executed that one too as well. And they are asking for the DNS server address. So the DNS server address is also there. Okay. DNS server. Okay. This is the DNS server address 10.2.0.125. That's the DNS server address. All right. So document the IP address settings for net admin. So let's locate the device that is net admin, this wiring closet. Okay, so for the net admin, you have to click the wiring closet. In the wiring closet, then you click on the device that is net admin. So I think this is it, net admin. Then you go to the desktop tab, you open command prompt, then you enter if IP config. Then here is it. We have the IP address here, and it's assigned dynamically using a DHCP server. And if we want information related to the DNS server, we have to type ipconfig all. So let's do that at once. /all to view more details. So here you can see that the DNS server that is assigned to this net admin server computer or PC2 here is the same as the one on the HQ1 laptop. All right. So we have seen that as well. So part 2 is to gather information about network devices. So the very first step is to gather network connection information about the link between HQ and the ISP. So in the wiring closet left rack, click HQ edge 1. So I'm going to click the edge 1. So if you don't know the device, you hover over it, then the name will be available. HQ edge. Okay, so this is it. This is the device HQ edge. So we are in. Let's look at the rest of the instruction. So you press enter, then you enable the terminal. After enabling the terminal, you enter the show IP right or begin gateway. So let's look at that quickly. Let's go to the CLI in the router, enter, then say enable. Say show. So when you enable it, you will see a hash at the prompt. Show IP route. Then press the pipe command. That's the pipe symbol. Command is begin gateway. So you start the sync or you start the router. Begin gateway. Then press enter. All right. So here are some valuable information that have been displayed to us. We can see that there's a subnet mask here, and we have 6 subnets, 4 masks. We have the various interfaces that are on the router as well. And this another interface here with 2 subnets. So you can see the 2 interfaces that are available. So you see 1, 2 interfaces, and they are directly connected. Here too, they are directly connected. You can see with here with a different IP address and the various interfaces that they are connected to here as well. So, okay, let's proceed here. So what is the address for the gateway of last resort or default gateway? So let's pinpoint that. So this is it. Gateway of last resort is 0.0.0.0. So this is it here. It has been highlighted. And also have the next question is, why is the next hop address not displayed? The next hop address. Next hop address. Let's see. Address. They are asking for the next router address not displayed. Okay, so the next hop address has not been displayed yet. I think because we have not made transferred anything to that device yet. So like when you want to route a packet to that router, then you build that router or that router's IP address into your router's table. So this is the routing table. Here we are seeing the various IP addresses and their interfaces that are connected to the system. So the next hop router is not, we don't have its IP here because we are not transferring anything to it yet. So when we started transferring something through that router, or when we start routing through it, then we have to record it in our and like in our HQH router. So, or in other words, because it is not directly connected, right? So you also enter another command, that's enter the show running config begin IP route command. And how is the default route configured? That is, use the next hop address. So this time around, we are going to use show running config begin IP route. Show running config, then the type begin IP route. So right, so there is it. IP route is also 00 as compared to this one here. I think this one here, last resort. So they are asking whether this in this command, does it the next hop address? Let's look at that. No, the next hop address has not been displayed as well. Okay. So the last command for this one is you enter the show CDP neighbors detail command. So I think the routers that are like the routers that, let's say the neighboring routers, that's what you want to show. So we'll be on one router and show that. So show CDP neighbors detail. So CDP neighbors detail. CDP neighbors details. Neighbors detail. So the command is show. Okay, so you can see some information here. The device ID is ISP. So the platform. Okay, it's just information about the current router. Like, let's proceed. So what is the IPv4 address? So that one you can look through and look at that. It's consuming much time. What iOS version is used on the ISP router? So they are here as well. They are here. All those information are here. You can use it and document that one. You are lost. Don't be lost. Just enter the commands and the various questions that are being asked. like after you enter the commands, when you read through, you get the answers below to the questions, then you just enter them. So that's it. So when you want to test for connectivity, you use the ping command. So enter the ping 10.0.0.49. So let's ping that IP address. So ping 10.0.49. So it's pinging it. It's taking some time to ping that device. Oh. Hmm. Yeah. I think I use 10. So it will take a while for it to go and come again. Um, okay, it has crashed for now, so like it will take a while before like this place will be released. I've entered the wrong IP. It has been released for me to use. Ping 10.0.0.49. All right. So we are done. So it has pinged it. So it's a success 100%. Okay. So there's a connectivity. Let's show the app information. That's address resolution protocol information. So let's just show the app. So here is it. So in the app table, we can see that this is the IP address we pinged just right now. And we can see its associated MAC address is this. And the interface on which it has been connected. Right. So we have to exit the wiring closet. Next is to gather network connection information about the devices in HQ. So we have from PC1, PC2, PC3, and PC4. So 1, 2, 3, 4, and the printer here. So you use the ipconfig command to find and document their IP version 4 addresses and default gateway. Since like you guys know how to use the ipconfig command already, you have to do that on your own. You just enter. So I'll repeat one. When you enter here, you go here. From the desktop tab, you click on command prompt. You enter ipconfig. Then hit enter. Then you have the default gateway and the IP address. Then just document that information. Let's proceed. You also from the PC1, you open command prompt and then enter the app-a command. So when you enter the app-a command, you want to look at the address resolution protocol. So let's enter that app-a. So we are going to view the MAC address table. So there's no entry found. All right. So they are asking for the information that have been displayed. No entry found. So now for here, no entry has been found. But for here, when we make a connectivity between the PC, this PC and the HQ laptop, when we now enter app-a, we will find information in it. So I'm only going to test connectivity between this and this, but for the rest, you do it on your own because of our time as well. So this and this, so the IP address of this is 192, the laptop, 192.168.50.4, and the IP address of the PC is 192.168.10.5. That's PC1. So we are going on PC1, we'll ping the laptop, right? So let's go and do that. Ping 192.168.50.4. So we are waiting. So first packet has timed out. Okay, the rest went through successfully. So it means there is a connection between them. Now let's enter the app-a. That's ARP-a. So you can see in our address resolution protocol table or the MAC address table, we can see there is a MAC IP address associated with a MAC address in it now after pinging this command. After testing for connectivity to the HQ laptop. All right, so you can go ahead and ping the rest, then verify the MAC address and its associated IP addresses using the app-a command. So they are asking that, why is it that even though those devices are on different network interfaces, so they are asking that, why is it that, so I think we should ping one additional PC again to verify the difference. So this is on .20.4. So let's verify that, so for me to clarify this out. So let's ping it. So 192.20.4. So when you ping 192.20.4, to take a while for it, because this one is on a different network. So it has come. So we'll check the app table again to see what's actually going on. So here we still have one. That is because the answer to this question is because those PCs we are trying to ping, they are on a remote network. So when you want to access a remote network, the IP address that will be recorded in the app table is the IP address of the default gateway. This one, 192.168.10.1. So that is why we are having 192.168.10.1, because these devices, they are on a different network. So for us to access them, we have to use the IP address of the default gateway, which is that of the router. So that is why. So to find the route a packet takes to reach the DNS server, you have to enter the trace route and the IP address. So the IP address here is 10.2.0.125. So we are still on PC1, so we are going to trace the route. So 10.2.0.125. So let's trace the packet. Trace it. I like using the trace route in Linux. That's why I'm always mentioning trace route. Okay, 10.2. I think 125. So let's trace it. Up. That's bad. IP. So I got so it should be .0.125. Let's go now. Yes. Yes, so you can see at the first round, it took us 46 milliseconds for us to get the so this is our default gateway on PCA, on PC1. And now the next router it met on the way is this one. This is the next router or the next hop it met before it has finally reached its destination. So it has to pass through 3 hops. So it passed through 3 hops before it will get to its final destination. So 1, 2, 3. The one here, the default gateway on the network in which we are trying to test it on. So they are asking how many routers or hops are between PC1 and the DNS server. There are 3. Also, the last of all is to diagnose connectivity issues. So in this part, you will use a variety of diagnostic commands and techniques. You will use the nslookup command to query a DNS server and troubleshoot a DNS database. You will then diagnose why a ping fails but web access is successful. Finally, you will use the netstart command to discover which ports are listening on the target device. So this one, you have to be snappy here. On PC1, so we have to close the command prompt and go to the web interface. So we close the command prompt, go to the web browser. Then we'll navigate to test.ptsecurity.com. Okay. So let's navigate to that test.ptsecurity.com. So it will take a while. The next thing is does the web page display? If not, what is the message? So let's wait a minute for it. Still loading. I think let's fast forward the process. Oh, fortunately, it's not responding for a while, so let's be patient. Okay, so we can see the information is host unresolved, host name unresolved. All right. So it means the DNS is not working on the system. That's why we've gotten this. So you cannot access the web interface using a domain name. I mean the website using a domain name. So we are to enter the IP address so that we can access the web page. So we are going to enter 192. So 192. Dot 168 dot 1075 dot 2. Then this one, so it has finally landed the page. This is test.ptsecurity.com site, but unfortunately we cannot access the site using the domain name because there is a problem with our DNS server on the system. All right. So we have to close the web browser, move on to the command prompt. Next is to then now we'll ping the test.ptsecurity.com command and see whether it is reachable. Right? Ping test.ptsecurity.com. So ping request could not find was test.ptsecurity.com. So please check the name and try again. So now we are not reachable, so we have to look at the NS lookup. We'll perform an NS lookup on it to troubleshoot the DNS server. So the server is 10.2.0.125. That's the DNS server. But on that DNS server, we don't have any domain name that is test.ptsecurity.com. So it's returning unknown. Can't find test.ptsecurity.com. So the domain doesn't exist. So that's why we cannot access it. Right. So that was the message that have been displayed. So you record that one as year 2. So they're asking of the default server for the DNS server. That is there. You just record the IP address. That's 10.2.0.125. So the NS lookup command supports the use of alternate DNS server. So you enter the NS lookup / question mark command to learn options available for the command. So you can do that to learn the options that are available. So next is to enter NS lookup, then the domain name that we want to associate with the given IP address, then we enter. So let's look at that. Let's copy and paste directly. Okay, so let's do NS lookup / question mark to learn about the command. So here is it, NS lookup interactive mode using default server, NS lookup host, just lookup host using default server. So it's just some brief information that is there. NS lookup host ABCD. So just lookup host using the DNS server with IP address ABCD. So let's paste this. So we are entering any command that's NS lookup, then the domain name we want to associate with that server. Let's enter. So now we can see here, it's in the server. Now we have given it a server on its own. We are not using the default server that we use here. So now we have given it a new server. This is it, the 192.168.99.3. So here we can now see the authoritative answer is
You cannot lay bed. What do you want to do? Okay, let me.
the domain name and the address that is associated with it now. So now let's do ns lookup test.ptsecurity.com. So when you use it by default without the server that has been associated with, you get error. But when you assign the server name to it like this, the domain name and the server, then you locate it, like you locate the domain name and the server on which it has been registered. So more on this, we'll use
Pardon my
so
interruption,
I think
Instructor
you can
Isaac.
now. Yes, madam.
Sorry.
Yes, madam.
Peter Ikpeku. Peter, oh, don't divide this class for us. Oh.
Okay, let's proceed. So now thing is to enter ping the a given domain name. So I think this we can do it on our own as well. Then you enter ping, then a given domain name again. Then now you close the command prompt. Then you open the web browser, you check it again, then you draw a conclusion. So I think that should be way more easy to do on your own because you have tried some of them out. This one, the next one is you close the web browser, you open the command prompt. In the HQ, you click on the wiring closet here. So you click on the wiring closet.
Please, mic now.
So now you click on the FTP server. So this is the FTP server.
Sorry, Instructor Isaac.
All right, madam.
Anytime it's like this, you don't have to talk. Don't worry. We are here to do the needful. So, because as he's interrupting us, when you also talk, you will be interrupting the instructor. So don't worry. We know what to do to people like that. We have excuse us for the night.
Okay. So we are using this. So we have to adjust it side by side. And the server as well, we have to adjust this, the FTP server. Go to the command prompt of it. All right, so let's look at our objective now. So on PC1, we have to enter the net start command to look at the various connections. So this PC1, net starts. So enter the net start command. At the moment, there are no active connections available. All right. So they're asking for the message that was displayed. Was there any data? No, there wasn't any data. So on the FTP server, we'll enter IP config. So let's quickly do that. IP config, IP config. So here is it. There's an IP address associated with this server. Okay. So on the FTP server also, we have to enter net start command to see the various connections. So net start. So for this one, we have some connections. So the protocol type is TCP, the local address and the foreign address. So the local address and port combination. So we call this socket. So the socket combination is called socket pair. So this IP address from here to here. So an association of IP address and its port number is called a socket. And like the local address and the foreign address will now be called a socket pair. All right, so this is the connection that is open on the local system, and this is the connection that is open on our foreign system that will be interacting it. In other words, the remote system and its associated port numbers. So you can see a colon between the IP address and their port numbers. So the state of these ports that are available is that they are closed. We can see that there is port 25, which is SMTP. You can see that there is port 1110, which is NTP, that's Network Time Protocol. So the state of it all, they are closed. Right. So they are asking for the message. So what you see is what you display as well. So from the PC1, you enter Bob. From the FTP server, enter the net start command. From PC1, enter Bob as the username. So I think we are going to make connection to the FTP server. So before we'll be successful on doing that, we have to know the IP address of the server. The IP address is 192.168.75.2. So that is it. Then we should enter Bob as the username, and the password is Cisco 123. All right. So let's go to PC1. So FTP 192. So we are logging into the FTP server 192.168.75.2. As for the username, we say is Bob. Password is Cisco 123. Okay, so we have been given the FTP prompt, so we are in. So we list the directories in the in this particular FTP server. So by entering the die command, so it's listening the FTP directory. Currently, there are no directories found. There are no folders. So from the FTP server, enter the net start command. So we now continue by entering the net start command on the file server to see the open ports. So now you can see that the a communication has now been established between, so this is our local address, is on the FTP server. So here, you see this is the IP address of PC1. Take note of it. 192.168.10.5 and a randomly generated port number. So that's the source has generated a randomized port number, but for the destination, that one it will use a well-known port number. So that's port 21 for FTP services. So the connection has been established. So let's look at this. So when you take a look at PC1, you realize that the IP address is 192.168.10.5, and here too the foreign IP for foreign address, which is the remote system. So on this system, this IP become foreign. On this system, the FTP will now become the foreign. So let's type the net start command. So we are still in the FTP server, so we can type the net start command. Let's see this. Now we'll close the command prompt, then we'll navigate to the web interface. Then we'll go to 192.168.75.2. Then I think we'll display more connections to the on the FTP server. So let's look at it. So mind you, the FTP server's IP address is the 192.168.75.2. Yeah. Sometimes the browser responds very slow, so please be patient. So now let's see 192.168.75.2. So now we have accessed a web service on our FTP server. So this is it. So now let's look at the net start command again to view the necessary connections that are open. I mean, the ports that are open. So let's look at it now. So this is it. Can see here, even though we were successfully connected to that interface, but nothing has shown that we were able to connect to the FTPs, I mean the web interface, because this is an FTP server. It's not a web server. So let me see. But we use that IP to connect successfully. So if there's a connection, then it must be established here. So let's type the command again. Still, there is no if there were to be port 80 here, then we say this connection has been established successfully, but still we were able to access the web page, right? So that's it. So that's how come you display the various information about this. So actually in the real world, you have to use the command prompt. So let's see the CMD. So this is it. So with the various commands that we run, I'll first start by showing you some real world examples. That's let's test connectivity to cisco.com to see whether we can access their site. So ping cisco.com. So you see, you are able to access, we've gotten a reply. So it means there is a connectivity. And the next command is let's check whether our this one DNS server is working. So ns lookup cisco.com. So it is working. And this is the address. This is our server address, and this is the address associated with the Cisco.com. This is it. That's the IP address associated with it. And the other command we learned about is the net start, the connections on our system. So let's look at the connection on my system. So you can see here, it's here to be displayed. So you can see there's a TCP protocol, the local address, the foreign address, and the state. Here, the various services have been established. Here, instead of using port numbers, they use the short, the protocol name, that's HTTPS, which is port 443. So that's a real world view of what we were doing in Packet Tracer. And I think we also have one command that's IP config, so which is the same thing we'll do here as well. So you can see IP config, this is my wireless LAN adapter, and this is my IP address. Yeah. And the default gateway. So this is the IP address of my router. So if I want to share information on the between my a remote network and my LAN, then this is the default gateway that I will use. Sure. So that is it briefly. So we are done with this Packet Tracer. Let's just close it and practice it on your own thoroughly to understand the ping command, the net start command, and the other commands. All right, so let's proceed with our presentation. So the next is network security testing techniques. So we have in the operation security, like the operation security is concerned with the day-to-day practices necessary to first deploy and later maintain a secure system. So that's actually what the operation security is about. Is the day-to-day practices that are necessary to first deploy and later maintain a secure system. All networks are vulnerable to attack if the planning, implementation, operations, and maintenance of the network do not adhere to operational security practices. So once you fail to adhere to the operational security practices, your network is vulnerable to attack. Like under normal circumstances, every network is vulnerable to attack, but you still have to undergo or follow the operational security practices so that you can mitigate some of these vulnerabilities. Operation security starts with the planning and implementation process of a network. So during these phases, the operations team analyzes, designs, identifies risks and vulnerabilities, and makes the necessary adaptations. The actual operational tasks begin after the network is set up and include the continual maintenance of the environment. These activities enable the environment, systems, and applications to continue to run correctly and securely. Let's proceed. So let's look at, so for you to be able to, use this technique, some of the operation security practices are done manually, whilst others are automated. So before you be able to successfully follow these operation security guidelines or practices, you have to have some skills or basic skills in operating systems, basic programming like maybe C++, Python. Then when it comes to operating system, you have to know more of Linux, Windows, Ubuntu, and the like. Also, you have to know networking protocols such as the TCP/IP and also the OSI model. You have to know all this. Then the network vulnerabilities and the risk mitigation, the various vulnerabilities that are in network devices, like the default password, the missing patches, and the like. Then also you have to learn device hardening. So you have to change default passwords, you have to update the system, you have to ensure that all user accounts have passwords on it. Yeah, so that's example of device hardening. Also use firewalls. Then IPS, you have to have knowledge about all this technology, the IPS and the firewalls as well, and device hardening. So firewall, what it actually does is what? It acts as a like, it's analogous to a security man standing in front of a house, allowing some people in and denying some people access into their house. And we have various types of firewall. We have stateful, we have stateless, depending on what you want to use it for, like, and the amount of money you have, then you go in for the one that best you. I also have the IPS, which is the intrusion prevention systems. So, and it prevents malicious packets from entering the system. Any packet that is malicious or that seems to be an intrusion to our organization, it has to prevent it from entering it. Whereas IDS, which is intrusion detection system, it only detects a malicious packet, but that one will not be able to stop the attack. All right, let's proceed. We also have the testing and evaluating of network security. For the effectiveness of an operation security solution, we have to test without waiting for a real threat to take place. So you always have to test the network before waiting for a real attack to take place before you begin testing your security posture. Network security testing is performed on a network to ensure all security implementations are operating as expected. So when you perform network security testing, you ensure that, so let's say you run vulnerability scans on your system, you determine whether some people are using default passwords. You also determine whether there are some misconfigurations in the firewall. You determine whether the services that are running, are they outdated? And also you determine the accounts that are available on your system. By so doing, you are evaluating the security posture of your network before an intrusion occurs. So you are reducing the possibility of attackers scanning the network by gaining information. Then they will then utilize that information to make a weapon to exploit your system. Typically, network security testing is conducted during the implementation and operational stages after the system has been developed, installed, and integrated. Security testing provides insight into various administrative tasks such as risk analysis and contingency planning. It is important to document the result of security testing and make them available for staff involved in other IT areas. So during the implementation stage, security testing is conducted on specific parts of the network. After a network is fully integrated and operational, a security test and evaluation is performed. An ST&E is an examination of the protective measures that are placed on an operational network. Time is fast spent. Let's be snappy. So let's look at some of the objectives of the security testing and evaluation. One is to uncover design, implementation, and operational flaws that could lead to the violation of the security policy. We also determine the adequacy of security mechanisms, assurances, and device properties to enforce security policy. So you also determine the kind of techniques that you put in place to enforce that the security policy is being like used to, let's say, maybe you put there's a security that's related to password policy or bring your own device policy. You must put mechanisms in place so that those security policies are being enforced. Then also you assess the degree of consistency between the system documentation and its implementation. Tests should be repeated periodically and whenever a change is made to the system. For security systems that protect critical information or protect hosts that are exposed to constant threats, security testing should be conducted more frequently. So security testing is not just a day job that you say because we have done it today or we have done it this season, the next season we will not do it. We have to be doing it frequently. Some people might choose to do it every 3 months. Some might choose to do it every 6 months, depending. So it is always better to hire somebody to perform the security testing for you rather than you waiting for you to be exploited first by an attacker before trying to fix things out. So you must constantly be scanning your system to determine vulnerabilities. So we have some types of the network tests. So the threat actors, they use reconnaissance techniques to learn about network as they search for vulnerabilities. So reconnaissance is all about gathering information about the network. So the more information you have about your target, the more likely it is for the attack to be successful. So if you have more information at hand, and you can use that information to develop a weapon to attack your enemy. So the reconnaissance aspect of it, some are active and others are passive reconnaissance. When we talk of passive reconnaissance, you are making use of the information that are available about an organization online. So you are using publicly available information, like also maybe it can be a Facebook password that have been linked and the details are on the dark web. It can also be the company's domain name, the employees that work there, their email. You harvest all those information. All these fall under the passive reconnaissance, and also open source intelligence gathering or OSINT. These are also publicly available information that will help both security testers or the penetration testers and the threat actors as well. So it's used by both. And when you talk of the active reconnaissance, that's where you make direct interaction with the network systems to gather information using tools that are used in penetration testing, like you use Nmap, HPing, Superscan, and the like. We have more testing techniques. That we have one is penetration testing. This is where you simulate a real world attack. So you behave as if the source is from a malicious point of view. This is where you have to like hire somebody to perform security testing on your system for you. So it's different from vulnerability scanning. For the vulnerability scanning, you only detect weaknesses in the system and the misconfigurations, the default passwords, the potential targets for the DOS attacks. But for the penetration testing, after you have identified the weaknesses, you go on by exploiting these weaknesses to see how to see when attackers discover all these vulnerabilities, how they will be able to, exploit the system actually. Yeah. We also have the network scanning. This includes software that can ping computers, scan for listening TCP ports, like we did. We use the netstart command to view the open connections on our system. So we realize HTTPS is running with its associated IP address. Like, let's say this. So when you come here, you see HTTPS. So it tells us that port 443 is open and the IP address that is associated with that port. And also you determine the usernames, the groups, the shared resources that are on the system. Nmap is a tool of choice that can do all these things for us. All right, let's proceed. We also have the password cracking. So for the password cracking, this one will help you to determine the like the weak passwords that are in the system. So some of the passwords are weak. So when you perform a password test on the system, when there is a weak password, you only inform your employees to change that password in order for them to match the password policies. You also do a log review on the system. So system administrators should review security logs to identify potential security threats. Anytime a device logs into a system, a message is generated and recorded into a log file. So this message is called log. So like the IP address of the device that has connected, the time at which it has connected, the resources that it has accessed. So the network or system administrators have to be constantly viewing these log files in order to detect any abnormal activity on the system. Also, we have the integrity checkers. So the integrity checkers, they are used to determine whether the system has been modified or any changes that have been applied to the system, either being the network system or the computer systems. We also have the virus detection, where you use anti-malware tools to remove computer viruses and other malware from your system. We have another one to that's wall dialing and wall driving. This is where you put your Wi-Fi interface card in monitor mode in order to capture all the packets or the frames that are being transferred to that have been transferred by all the wireless APs that are in range. So by so doing, you can capture the frames and crack their password and possibly connect to those APs and use for free. So let's proceed. So the result of a network security testing are to network security testing results can be used in several ways. So the uses of the network security testing results: when you have successfully conducted a network security testing, you have kept record of all the activities that have taken place. What will those information help you do? One, you define mitigation activities to address identify vulnerabilities. Like you apply patches to the outdated services, you disable or remove the accounts that are not allowed to be on the system. Maybe there's a password vulnerability, you change the password to a very stronger one, of course, and also serve as a benchmark to trace the progress of an organization in meeting security requirements. Okay, so that's you meet the compliance regulations. To assess the implementation status of system security requirements. So that's by evaluation. To conduct cost and benefit analysis for improvements to network security. You also enhance other activities such as risk assessment, certification, and authorization, and the like. Let's proceed. So the next is for us to look at the network security testing tools. So we have been mentioning these tools over and over, the Nmap. So let's quickly look at these tools. So the Nmap is used to discover computers and their services on a network. So it will create a map of the network. I think we have looked at that already. We have the super scan. This is the one we use on Windows. So this one is also used to determine the running ports. It's used to run queries. It also uses the who is, the ping, the trace route, and the host name lookup, which is similar to the NS lookup. So it has incorporated the various functions, like we have the who is command, we have the ping, we have the trace route. So it has incorporated all these functions or all these commands into one tool set that you can use in the super scan. So the super scan can replace the ping command. It can replace the ping, the who is, the trace route. Yeah, so all those functionalities that they can provide you, the super scan is able to do all that. And for the SIM, we discussed about that one too, but it's just a technology that is used by enterprise organizations to provide real-time reporting and long-term analysis of security events. You also have the GFI's Langa. So this is a network security, it's a network and a security scanner which detects vulnerabilities. So it's a vulnerability detection. So see it? We have the Tripwire. So this tool assesses and validates IT configurations against internal policies, compliance standards, and security best practices. Take note of this very well. These tools, their definitions, it comes in section 8 situations most at times. So the tripwire. So you access and validate the IT configurations against internal policies, compliance standards, and security best practices. They also have the Nexus, that's a vulnerability scanning software. And you have the Loft Track, it's used for password auditing and recovery application. Then we have the Metasploit, which is the network. That's the Metasploit framework. It's used for exploitation. So whenever you determine vulnerabilities in the system, you can use the Metasploit to exploit that vulnerability. So all these tools, some of them are open source, that they are available for us to use for free, and others are commercial. So for the Nexus, we have a free service of it that I think you just use it for the first 7 days or maybe some limited number of scans that you can perform, and you have to apply for the commercial service of it in order to use it. But for the Metasploit, it is open source. Nmap as well is open source. So some of them are legacy tools. Let's take a look at those ones on the next slide. So the Nmap, it has been there for a very long time. So it's used for network mapping. It's used to perform reconnaissance of the network. So you view all the open ports and the services that are running. You can determine the groups, the shared resources, the usernames that are on the system. They also used for OS fingerprinting. So let's look at the basic functionality. We can perform classic TCP and UDP port scanning. So it will search for the different services on one host, and the classic TCP and UDP port sweeping, it will search for the same service on multiple hosts. So these are capabilities of Nmap. It can perform a stealth scan too. This is to avoid detection by the IPS and the IDS. It can also do a remote OS identification, which is also known as OS fingerprinting. It will determine the OS that the system is using. Let's proceed. Advanced features of Nmap include protocol scanning, which is also known as layer 3 port scanning. So the very basic use of Nmap is to scan for open ports on a network and also display routing protocol information, that's the GRE and the OSPF. For the OSPF, that's open shortest path text. These two are routing protocol. So that's Nmap for us. We have a graphic interface for Nmap. That's what we term as the Zen map. So Nmap can be used on a Linux or Unix system. It can also be used on a Windows system. It doesn't have any application layer feature. So it runs on, like, it is for a cross-platform purposes. It is publicly available for you to download, so it is open source. Let's proceed. We have the SuperScan. The SuperScan is a Microsoft Windows spot scanning tool. It runs on most versions of Windows and requires administrator privileges. The SuperScan version 4 has a number of useful features. So these are the various features of the SuperScan: adjustable scanning speed, support for unlimited IP ranges, improved host detection using multiple ICMP methods, TCP SYNC scanning, UDP scanning, or the two methods, simple HTML report generation. So you can take a screenshot of this for the purposes of examination. But if you are exploring the tool, you can read more on it. Let's proceed. Tools such as Nmap and SuperScan can provide effective penetration testing on a network and determine network vulnerabilities whilst helping to anticipate attack mechanisms. However, network testing cannot prepare a network administrator for everyday security problem. Right, so let's proceed. We have the SIEM here as well, that's security information event management, which we possibly look at in the previous slides, where we say they provide real-time reporting and long-term analysis of security events. So it's just used for security monitoring. So it will gather information from many different sources. So the essential functions of the SIEM and the SIEM tool is to provide, so these are the functions it provides. So correlation, so it will examine logs and events from different systems or applications. Then it will speed the detection and the reaction of security threats. It will also aggregate by reducing the volume of the event data to consolidate duplicate event results. It's also useful for forensic analysis. So various events that are being gathered can be refined to gather evidence about an incident. I also have the retention. This is where we have, it's like we make reports and long-term summaries of the event that has been occurred. The event that had been recorded. So let's look at the continuation. So SIEM provides details on the source of suspicious activity, including the user information, that's the name, the authentication status, location of the user, the authorization group, quarantine status. So the information that SIEM collects, it can be used to identify suspicious activities that include the user information, the information about the device, which is the MAC address, the manufacturer, the version of the OS, and the like. Also, the poster of the information poster. That's device compliance with corporate security policy. So the devices that are running in the organization, do they comply with the organization's security policies? And below are a few questions that are to be answered by a network security engineer to quickly assess the significance of any security event. So who is associated with this event? Is it an important user with access to intellectual property or sensitive information? So whenever an event is generated, you ask the various questions that are displayed here below in order to find out more details about that event. Let's proceed. So our last subtopic is penetration testing. Okay. So what penetration testing simply means is simulating real world malicious attacks to actually exploit weaknesses in systems. So you are using the techniques of the threat actors to test the security posture of the organization, but you are being employed by an organization. So you are being authorized by the organization. So you enter into a contract with the organization for you to perform the penetration test. So I said earlier that a penetration test is different from a vulnerability testing, whereby you go a step further to exploit the vulnerabilities that have been discovered. But for vulnerability testing, you only discover the vulnerabilities in the system. All right, let's proceed. So the penetration testing is a subset of ethical hacking. Let's proceed. So we have different exercises that can be performed. So like the information that is available at your point before you are performing the penetration test. These are the various ways. We have about 3 different ways. That's one is black box testing. So with the black box testing, you have you don't have any information at hand. You are simulating a threat actor who don't have any prior information about the organization. So you will start by researching about the target online. Then after that, when you get some domain name, you perform you resolve the domain name to IP address. Then you now scan for those IP address. That's we progress to active scanning. Now that when you determine the vulnerabilities that are in the system, then you can be able to go a step further by exploiting those vulnerabilities. Whereas the gray box testing, this one is a combination of the black box and the white box. With the gray box, you, the penetration tester, you have some knowledge about the system that you have been hired to test. So it's like they can provide you with information such as the company's domain name and like some of the emails of the members in the organization. Let's say you are going to perform a social engineering attack. So so maybe they can give you some of the members in the organization their email for you to simulate a social engineering attack to see whether the employees are aware of the security. They are aware of the current security. I mean, they are conversant with the security policies of the organization. Like when it is a phishing email, will you be able to recognize it and prevent it from tapping on it? Or maybe when it's like a file looks like a malware, the link is a malicious link. Will you be able to distinguish between it? So they have to provide the gray box tester, the some email, the domain name, and some other information about the system, and equally IP addresses. So here too, even though they have knowledge, but it's a bit limited. But for the white box testing, this one, it consumes a lot of time. So it is performed by a specialist that have enough knowledge about the organization. So all the information that is needed by the penetration tester, which is the white box tester, is provided to him. So he can spend about a month to complete their job. So it's actually expensive. Let's proceed. There is also another which we call the bug bounty. That one you are and go back a bit. That one you are trying to discover vulnerabilities that are not known. Those are 0-day vulnerabilities. When you discover a 0-day vulnerability, you'll be paid or you'll be rewarded for it. Yeah, so we have the bug bounty harvesters as well. Let's proceed. So let's look at the methods or the phases of a penetration testing. Number one phase is to plan. That's where you establish the rules of engagement for conducting the test. You have to sign and enter into a contract with the one that have employed you, so that when there are any like misunderstanding, you have a proof of document to defend yourself at the court. And the phase two is the discovery phase. That's conducting reconnaissance on the target to gain information. This can include passive techniques which do not require active engagement with the targeted system and are referred to as footprinting. So this is where you search online for publicly available information about the organization, and also the active reconnaissance. So let's assume you have gathered information about an organization. Let's say we've gotten their domain name. So as we've gotten their domain name, we can go by resolving that domain name to IP address. So now that we've gotten the IP address, then we can now proceed by performing an active reconnaissance by using Nmap on that IP address. So we are now interacting with the target directly by probing their system. That's actually active reconnaissance. Yes, ma'am. Please, I'm in class. All right. Sorry about that. Okay. Yes, let's proceed. Phase three is to attack. This is where you actually exploit the various vulnerabilities that you have gathered in the system. So you can go a step further by making lateral movements, like when you compromise one host. So you've got into the network. So now you can start moving from one device to another. That's a lateral movement. So it is always a best practice to put a measure which is called network segmentation into place, so that when attacker gets into one part of the network, they will find it difficult to extend the attack to other parts of the network. So network segmentation is actually important by way of using routers. Also, you can install backdoors to avoid detection, so that you can remain in the system for a longer period. That's what is known as persistence. You hide the activity that you are performing in the system. So finally, you then clean up the system and remove any signs left behind. Then the last phase is to report. So you document all the vulnerabilities that you have identified. Then you provide the organization with remediation techniques that they have to follow in order to secure their systems. Right? Let's proceed. We also have some of the exercise types. That's the various teams that fall under the pen testing category. We have the red team. These are the adversaries, like they act like the threat actors. And we also have the blue team. They are the defenders. So they are protecting against the red team, the attackers. And you have the white team. These are the neutral team that defines the goals and rules and oversees the exercise. So they don't have much technical abilities or much technical knowledge. All they know about is governance and compliance. So they act as the referee between the defender and the red team to see whether they are complying with whatever assignment they have been assigned to do. We also have the purple team, where the red team and the blue team come together so that they will work together and identify vulnerabilities and explore ways to improve the controls. All right. We have the packet analyzer. So when you talk of a packet analyzer or packet sniffer, it's a tool that is used to intercept and log network traffic. So let's say there's a communication going on between two people on a network. There can be somebody in the middle, that's man in the middle attack, to capture their traffic and view whatever conversation that is ongoing between them. So it's just sort of if dropping the packet that is traversing through the network. For you to be able to do this, you have to put your network interface in a promiscuous mode. When it is in a promiscuous mode, it means that every device on the network, once they send a message that is not meant for your interface to, because your interface in promiscuous mode, it is listening to every traffic on the network. So it will be able to capture the traffic that are not meant for its that are not meant for that particular interface. So without it being in a promiscuous mode, you will not be able to capture other people's data. You can only be able to capture the traffic that are meant for your interface. So even though packet analyzers are used mostly for malicious purposes, it also used for legitimate purposes like troubleshooting the system, whereas the illegitimate purpose is to compromise data. So some of the purposes are network problem analysis, detection of network intrusion attempts, isolation of exploited systems, traffic logging, detection of network misuse. And the various tools that are used for capturing or sniffing of packets are, or the packet analyzers, which is also called a protocol analyzer, is our very best Shark. We also have the TCP dump. This one is a mistake. It's actually TCP dump. The Wireshark is a graphical user interface protocol analyzer. It can capture, intercept, or no, capture and intercept. But for the TCP, it's used for the TCP dump is used for on the command line. So this one is mostly good for the remote network. So when you log into a system remotely, because you don't have a graphical user interface, you have to use TCP dump. We also have the EtherCap, have the Kismet, ngrip, ntop, and EtherAPI. So the most widely used ones are Wireshark, TCP dump, EtherCap. Let's proceed. So the output of a protocol analyzer is in the form of a PCAP. That's the file has an extension that is a PCAP file. So sniffing is like eavesdropping on someone. It occurs when someone is examining all network traffic as it passes through their NIC, independent of whether the traffic is addressed to them or not. Criminals accomplish network sniffing using software, hardware, or a combination of the two. So as explained earlier, this is a brief view of it as well. Let's proceed. So one way to mitigate is the sniffing attack is the use of physical security. But sometimes it's not only used for malicious purposes. So when you are safeguarding sniffing attacks, you have to also consider it from the like monitoring point of view that network administrators also use it to analyze the network traffic, identify bandwidth issues, and troubleshoot other network issues using Cinefest. All right, so let's proceed. So we also have another lab here to do. For this lab, for you have to use the cybersecurity essential lab VM. Because my system crashed like some days ago, so I couldn't recover that lab. So I will be using Kali system to so that will quickly lab before so done with the we are done with this presentation. It left with the last lab work. So we are to go. Just going to be snappy. All right, so this is my Kali 25 machine. So let's launch the. Our first objective is to capture web traffic using Wireshark. Then secondly, we are going to use Telnet and SSH. Let's enter Wireshark. So open Wireshark. So you must make sure you are connected to the internet before doing it. Okay, so we are going to capture on any interface, or we can capture up on a Ethernet 0 interface, but let's just capture it on any interface. So promiscuous mode is not supported on any interface. So we'll not agree to that. Because we need access to promiscuous mode, let's run it as a root. So proceed with the sudo command. So sudo wireshark. So the access has been suspended. Wow. Let's open it again. Wait a minute here. Okay. All right, back now. Okay, so let's capture it on this interface. Start the capture. So when you have your Firefox or any browser open, then you have to see web traffics flying here at the moment. But because we don't have the browser open, so we've not captured any traffic yet. So the objective of this lab is to use Wireshark to capture web browser traffic. Secondly, to also use Wireshark to capture telnet traffic, and finally use Wireshark to capture SSH traffic. So Wireshark is a network protocol analyzer that lets you see what's happening on your network at a microscopic level. You can capture packets and store them for offline analysis. Wireshark includes many tools for deep inspection of hundreds of network protocols. In this lab, you will use Wireshark to capture and inspect web traffic, telnet traffic, and SSH. So let's continue. So you open your Firefox browser, then we can navigate to cisco.com. So because the browser is open, you can see some packets are flying in here. So we are opening the browser. So let's navigate to our favorite website. Let's say cisco.com. So as we are trying to navigate to that website, it is capturing those traffics. So we are on the domain, now on the page, cisco.com. All right, so I think we are done capturing that traffic. So we are going to stop the capture. So we apply the filter. So this is the filter field, and this is the packet list. This is the length of packets that have been captured. So the length of bytes for each packet. So these are the list of packets here. So the packet length is there, the info, the destination, the source, the time, and as well as the number. So just now, look at the number of packets we have captured. It's about, so the total packet is 5,195 just within 1 minute. Look at what we have captured already, right? So this part of it, we call it the packet list pane. And this side, that's what we call the packet details pane. And this side is what we call the packet bytes pane, like the packet bytes. So these are the various traffic that we have captured. Under normal circumstances, we could have gone a step further to this traffic. So in this, in this lab, we are only allowed to capture the traffic, but I don't think we are allowed to view details. But let me see. So I'll make a filter. I'll make a filter here. Let's look at our cisco.com request that we have made. Jesus. Kai. Oh, hello. Unfortunately, my PC has freezed. Kai. Shit. Hi, it has come now. So you can follow the packet, the stream. So this is it. You can see the request here, the request we make. we can view all this. So when you go a step further, the first step we did was just to capture the traffic. But when you follow the stream, going ahead by opening this side to look at the source MAC address, the source IP address, and the other details, then we say we are analyzing the packet. So you just choose a specific packet, then you analyze it here. So we are not to go into more details on this. In our subsequent lessons, we'll go into details. So now let's have a look at how to capture telnet traffic. So I'm going to open another terminal. Okay, so we'll capture a telnet traffic on our local host. The difference between a telnet traffic and the SSH traffic is that the whole of telnet traffic is not captured, but for the SSH traffic, it is captured. It's encrypted, but for telnet, it's unencrypted. So whenever you are transmitting through the network, something through the network, the whole conversation can be viewed by someone when you use the telnet protocol. But for the SSH, your traffic is being encrypted, so it becomes a bit difficult for the attacker to read what you are transferring. So for this web traffic too, when you follow the traffic here, you can see that it has been encrypted. But for the packet header information has not been encrypted. But when you view the packet details, like let's see here, like when you want more information on it, it will be encrypted. In the packet details here, the informations are encrypted. Let me clean this here and remove the filter. So web traffics are encrypted. So let me see. This HTTP. So let's see. Should be when it's encrypted, it will be HTTPS. Let's see. Nope. The information is actually clear. We can see everything. This is an encrypted version. The application data. Let's look at that one. Nope. There's no information available. This is what I'm referring to. So let's encrypt 1.0. So the information has been encrypted, so you will not see anything. Here is it. So web traffics are encrypted. So even we have captured the traffic, we are analyzing it, but we cannot see any useful or meaningful information here unless we use specialized tools to decrypt it before we can read the information. All right. So when you use telnet, to connect to a remote network, all your password and the username and the data that you are transferring will be displayed to the attacker or to anyone that captures that traffic. Sorry, my machine is running slow. That's why it's a bit slow. Okay, so we'll start the capture again to capture the telnet. So we'll continue without saving it to a file. Oh. Okay, now let's hit enter here. So the connection has failed. So let's see whether there's something wrong with my network connection. There's nothing wrong. Still failing. So that's how we actually capture the password. So when my connection is failing to connect, the telnet connection I'm trying to make. So let me just use the sudo command to see whether to come. It's still failing. So when it successfully comes, you just enter the IP, the password and the username. Then like the exception will be given to you to operate on that system. Then when you capture any traffic about that particular connection, it will be displayed in a plain text. So the idea is to tell you that the traffic in a telnet connection is unencrypted, whilst web traffic such as the HTTPS, they are encrypted. And also SSH, let's perform the SSH and get rid of it. SSH, so SSH localhost. So, okay, that particular port is not open on my system. So it's refusing the connection. So that's why it is advisable for us to use the CSE lab. When we use that, we can be able to do it without any challenges. Because this is a newly updated system, these services have been disabled by default. So if you want to use the service, you have to enable on your own before you use it. So let me see my other virtual machine, whether we can quickly look at that before we go. So I think this one is kind of vulnerable that we can use. Kindly permit me some 5 minutes of your time. Will end right now. Time is fast spent. Okay, so here. All right. Let's quickly open our Wireshark. Then we'll do the telnet and the SSH. Then we are good to go. As for the web traffic, we were able to capture that one successfully. Our system is running too slow. Pardon me for that. All right. Our terminal is here. Okay, so let's make a telnet connection and the local host. So still failing here as well. Okay, so I think at your own convenient time, you should use the lab that is being required. I mean, the virtual machine that is required for us to use. Because my system has crashed some time ago, that's why I'm not having that virtual machine. But in our next class, I'll try and get it before that class, maybe God willing Monday. So on Friday, I think Madam will be taking you, or my other colleague instructors will take you. Then on Monday, if I come, then I will. So somebody is saying you should run it as root. Okay. Let's see that. So still, connection is still refusing. It used to work, but okay, let's try the SSH one more time. For the SSH, you have to do it this way. I think for the SSH, you have to specify the username, like maybe a SSH, let's say Cisco at localhost. I think like this. Like this. Yes, then they ask you for the password. Then you type password. Hop. No, the password is Kali because I'm not using that virtual machine. The username is actually going to be incorrect because I'm not using that machine. So mine has to be Kali at localhost. Kali at localhost. Then password will be Kali. So I've been permitted. So let's just open the Wireshark and capture the traffic. I think it will now work. Sudo open. It's taking long for the Wireshark to load up. Okay, please, since it's not responding, I think we should do it some other time. Okay, because time is fast spent. All right. So I'll bring the class to a conclusion. Thank you all for listening. Thank you for paying attention. So in all, the Wireshark is used to capture traffic so that we can read the data that have been is sent across. For when it is a web traffic, the message will be encrypted. Telnet traffic, everything is unencrypted. When it is SSH traffic, everything is encrypted. So that's what I wanted to verify for you. But unfortunately, it's not working here. So God willing, Monday, I pray that the model we take should be less bulky so that I will quickly view this particular lab before we start. I'll work on it. And I'll download the virtual machine before that. So thank you all for listening. Before I release the mic to my very madam, I want us to share a word of prayer. Everlasting Father, we are grateful unto you this evening for how far you brought us. Father, thank you for your help. Without you, this class wouldn't have been a success. We are grateful. Even though we've encountered some challenges, but you are still with us. We are grateful unto you, Lord. Thank you, Father, for you have granted us understanding, for you have granted us wisdom. Father, as we learn on our own, grant us insight into everything that we will learn, that we will use it, it will be useful at the end, that our time that we spend in learning will never be in vain. Father, this and many others we ask in your name. Thank you for you have heard it. We glorify your holy name. In Jesus' name we pray. Amen. So, madam, please, I'm done for tonight. Today, I encountered some little challenges, but in everything, we have to give thanks to God. So, I just pray that I'll get a new PC and my subsequent classes that are yet to come will be more better than today. But we are grateful unto God as well. Right. Hello, madam. Hello, madam.
Sorry, can you hear me?
Yes, please, ma. Hello, ma.
Yes, I can hear you now.
Okay.
Hmm.
So, please, we are done. How to sing?
Yeah. Thank you. Thank you so much. Well done, everybody. Is a long one. So we make the recordings available so that most especially with the labs, David Bazzi is excited. So that with the labs, you can run
Madam,
over it.
please, for the lab, I told them that God willing, next week, Monday, I have to get the required virtual machine and redo the lab with them.
Yeah,
Mm.
it's okay.
Yes, because this one was giving me a bit technical challenges because I wasn't using the required lab.
Mm.
Mm.
That's what we always tell them. As we
Okay.
know, if it's not the one meant for the course,
Yes.
it will be giving you issue.
Uh-huh.
So, thank you so much, Instructor Isaac. I can't thank you enough. And thank you, everybody. I know we're about 50 or so that started the room, more than how I've dropped off because it's a long class. So, but like I told you, that's how it is. That's why we don't even want to bring in labs before, because it's going to take a long time. If you had all the time, let's say you have like 2 months or maybe even full 6 weeks, then we can be doing theory, then we do labs, we do theory, we do labs. So, but you don't have that time now. But we'll make the recording available. So please try your best, go over it again, and I'm sure it will make sense. So thank you very much, everybody. Does anyone have any question? Do we have a question? I know it's very late for some of us. Okay. If you have question, please, let's discuss it.
Can you hear me?
Yeah. I'm trying.
Can you hear me well?
Okay, yes, your hand is up. Is your one?
Yeah. What I want to ask, sorry, pardon me, ma. It's quite not related to this. It's not related to this model, but to model one. I wasn't available when it was taken. So I was like trying to get to see if I can find where the recording is so I can understand how the lab was done. But I couldn't find it. That was why that's my question. I want to know, like, because I'm having some challenges with the lab of model one, which is on the preparing these policy documents.
Okay, whatever challenge you have, ask on the group. We didn't do any lab.
Okay, okay. Okay.
We didn't do any lab during the class for module one.
Which is
So
on
what if
develop
you are expected to do the labs? So like I said, this module is an exception. So Instructor Isaac chose to run the labs with you.
Okay.
So, I mean, it's a plus. And you can see that it took the class from 2 hours now to 3 hours. So it's that extension of time that we're trying to avoid before. So, but we will still make it available. My team is trying. We had some technical issues. So when it is resolved, you will get the recording plus this one. Is that okay? Somebody said his head won't blow. Please don't let it blow. This head, we need the head. The head must not blow. We need the head. I'm trying to go through the chat and see. This summer, I think that answers you. Does it?
I will, if I have I'll ask on the group, sir. I'll ask on the group to permit more time because time is fast spent now. So I don't know.
Okay, yeah. So please always ask your question on the group. The instructors will be there. Instructor Isaac is not yet in the group. He will be in the group. Another instructor that will be taking you on Friday will also be in the group. So always ask.
Okay, ma. Thank you, ma.
You're welcome. All right. Those that are lost, don't worry, you will be found. It's normal. Even we where the teacher, we they lost. God will find you, okay? Anybody that is lost, we will announce you over the radio or television that you are lost. So that anybody that finds you can bring you back home. Somebody is asking if you can use Linux. I don't understand what you mean by Linux. Is it Kali Linux you are talking about? So what Linux are you talking about? I don't understand. Fair on me. So we recommend that use the resources provided by Cisco. You notice what happened to him. So it's still the same thing, but the one provided by Cisco is, how will I put it? It's meant for the course. So if you use another one, well, it will get you there, but you will not get exactly the same results. So that's usually what happens, because it is prepared, that those tools are prepared specially for the modules. If you said his head will spin, don't worry, it go clear. Just try and do it on your own. When you do it on your own, you will notice that it's no big deal. Okay, somebody is asking, why don't you run as root? Well, so I think you will have asked this one directly when he was doing the lab. Yes, David, go through it again on your own and you will understand it. Okay, somebody said we can start by 7. Okay, we will look into that. We will look into that. The challenge is I always have a midweek spiritual activity on Mondays. So, but that notwithstanding, if your instructors are available, you guys can carry on without me. So we will thank you very much, Victor, for the recommendation. We will look into it. And maybe I will say in advance also for the Friday class, if I discuss with your instructor and he agrees to 7, we might be doing it 7 p.m. West African time. Thank you, Victor. Cyber Chief said he has a question. What's your question, Cyber Chief? Is he still on the call?
Yeah, good evening, ma.
Good evening.
This question goes to Mr. Isaac. I don't know if he's still with us.
Yes, he is.
Okay. First of all, I want to thank you for the class. It was really insightful. That was not at some points with the packet tracer, but I'll go through it. So my question is based on the Wireshark. So while he was analyzing the packets, those ones that are encrypted that he could not analyze, he made mention that there are some higher tools that could decrypt those encrypted words. So I want to know if there are actually tools that could decrypt those things, because if there are tools, then why are they encrypted in the first place? Because attackers could take advantage of those tools, then exploit personal information that belongs to people. So please, I want him to clarify on that. Let me understand.
Okay. We will come. Instructor Isaac, are you there?
Yes, ma.
Okay. You got the question?
Yes, please.
Okay. Please go ahead and respond if you want to.
Okay, for the capturing of the packets, even though like the packet has been encrypted, there are tools there that they can use to decrypt it. When you know the like encryption techniques that have been used to encrypt the data. So somebody with advanced knowledge about cryptography, they are the ones that can be able to do it. But for like we beginners, like you won't be able to do it. But there are people with advanced knowledge that know how to reverse engineer the codes that are used in the encryption algorithm. Please, I hope I've answered your question.
Yeah, thank you.
Yes, you've answered it, but why is there encryption in the first place, since those people can decrypt what is already
Decrypt it.
encrypted?
Okay.
Let me just come in quickly. Okay.
All right.
You see, one thing we should realize in this industry is there is nothing that cannot be broken. Just take that. So we make efforts to protect, but that doesn't mean that what you are protecting cannot be broken. So there is nothing that has absolute security, nothing. So, and that's why one of the recommended things in the industry is defense index. So just one source of defense is not sufficient. So when you have layers of defense, it's helpful. But that does not mean that I mean, it's just like a strong password, for instance. It doesn't mean that very strong password cannot be cracked. It will only take more time. And that extra time is what your attackers don't want to spend. So it doesn't mean that if you have strong password, it can be cracked. It can be cracked. It will be a matter of time. So, but your attacker does not have that luxury of time, sitting with you, working on your password, just for him to crack it. You know, instead of doing that, we move on to the next next victim, because it might be successful over there. So the same thing with this. So like you said, you can have some higher tools that can decrypt whatever you encrypt. So now it is for you as a security professional to know that, oh, encryption alone is not sufficient for me to secure this data. So even though, yes, I'm encrypting, what else can I do to protect? Okay, so can I protect this data that it will not even get into wrong hand in the first place? Can I withdraw availability so that it wouldn't be the C leg that I'm focusing on? So I want to focus on all three aspects of the security, so that I make sure that this thing does not get into wrong hands. So just only one thing does not save all. Do you understand my contribution?
Yes, I understand. Thank you. So, which means that as cyber experts, if we want to protect our assets, we should not just base on one pattern of security. We should use layers of security to protect our personal information.
Absolutely.
All right. Thank you, ma.
To add to that, it's just like you have a password, a strong password, but you have to also use your facial recognition and other forms of biometric. That's something you have, something you know, and something you are. That's multi-factor authentication. So different layers of security to protect the data. Thank you.
Thank you.
All right. Thank you, Mr. Isaac. I appreciate.
All right. Thank you, everybody. So somebody is saying, I mean, and that's another thing we are considering here. Peter is talking about 7 p.m. might not be convenient for some, and which is true. Most especially for those in Nigeria, 7 p.m. might be very challenging. So for them, so, and another challenge we have here is we have other countries join us too. It's not just Nigeria. So like 7 p.m., 8 West African time is 7 p.m. for them in Ghana. So if we push it, then we are saying the Ghanaians will be joining by 6 p.m. their time, which may not be so convenient for someone that just finished from work. So, but let's try. I would say we maintain 8. Thank you for bringing this up. My mind did not go there. So I would say we maintain 8. We will try as much as we can to limit it to 8 to 10. I know it's not easy, but let's do 8. Let's limit it to 8 to 10 or 10:30 at the latest. So, ladies and gentlemen, thank you very much for coming. We really appreciate your presence. And on this note, I will declare the class officially closed. Good night, everybody.
Good night, ma.
Good night, ma.
Good night, Kikelomo. Thank you.
Good night.
Good night. Itama. Office
Good night,
scale.
Good night, everyone.
Good night,
Good night,
Sakachi.
Dr.
Efe.
Isaac.
Good
Yes, ma'am.
night.
Good night, ma'am.
Good night. Confidence. Good night. Tomiwa, Clifford. Good night, everybody. So, on the count of 3, I will be shutting down the room. Instructor Isaac, thank you so much. God bless you.
Bye-bye,
Thank you
madam.
very much.
Amen, madam.
We really appreciate it. So, on the count of 3, 2, 1.